Hi, quick video on higher order derivatives. Okay, so let's just go through what this is about. Okay, the derivative y prime, also known as the derivative of y with respect to x, is the first derivative of y with respect to x. Okay, the derivative itself may also be differentiated, which means you would take the change of something changing. So like the change of speed changing is acceleration, like we discussed. So the derivative in terms of x of the derivative of y with respect to x is the second derivative of y with respect to x. Okay? This will continue for subsequent derivatives. Okay? So this would be how we would write the third derivative with respect to x, the fourth derivative with respect to x, and on and on and on. Okay, once you get past the three little prime marks, you start putting a little 4 like that in parentheses, and that's how it's notated. Okay, so we're going to just kind of go through an example of taking these derivatives, and then you'll be able to complete your assignment and just get used to the idea. Okay, so here's our function y. The first derivative would be 5 times 3, 15, x to the fourth, minus 3 times 2, 6x squared, plus 2 times 5, 10x, plus 1, and then the derivative of negative 7 is 0. Okay, so this is the first derivative. If we take the derivative of this derivative, that would be our second derivative. So this would be 4 times 15, which is 60, x to the third, minus 12x plus 10. The third derivative would then be 3 times 60 would be 180, x squared minus 12. Now notice this said find all the derivatives. Eventually you run out of derivatives. So let's keep going. We're going to do the fourth derivative. It's just the derivative of the third derivative. Okay, I'm out of space there, so I'm going to come over here and go the fourth derivative of y, which we will write like that now. Sometimes you'll see it like that, which is in terms of x in that notation. Then 2 times 180 would be 360 x. The derivative of 12 is 0, so there's the fourth derivative. The fifth derivative in terms of x is 360, and the sixth derivative in terms of x, and you want to put those in parentheses to make sure it's clear it's not a sixth power, is 0. And that's all your derivatives that you have for this function. Okay, so just be aware that you can do multiple derivatives and how it's notated. Okay, we're also going to do a problem y prime. We'll do y prime in factored form. We'll do y to the second prime. We will do and leave it in our original form. Otherwise, it would become quite complicated. This is a quotient rule because we have x's in the numerator and denominator, which means my derivative of y with respect to x would be the derivative of the bottom times the derivative of the top. Now let me just say that again. The bottom, I said that wrong, times the derivative of the top, which is the derivative of e to the x is e to the x. So the derivative of 3e to the x is still 3e to the x. Okay? Minus the top times the derivative of the bottom, which would be just 2 over the bottom squared would be 4x squared. Okay? And now, since this is factorable, I want you to see kind of where this leads, because later in this course we're going to be setting things like this equal to 0 and solving them. If we had to solve this, we could factor out 3e to the x, but you can also factor out a 2. So you can actually factor out 6e to the x. So you might like it better if I write it 6x e to the x minus 6e to the x as my first step there, before I factor. Okay, so we are going to do one in factored form just so you can see where we're leading. So in this case, if you factor out 6e to the x, you get 6e to the x. You get x minus 1 over 4x squared. So later this will become a valuable thing that we'll be using. Okay, so that would be your first derivative. Okay, now your second derivative would be to take this and do the derivative of it using a quotient rule as well. Okay, so I'll go ahead and just kind of set that up for you. The second derivative would equal the bottom times the derivative of the top, which I'm going to write like this, and then do the math. And then you would have minus the top, which is all this stuff, times the derivative of the bottom. And I'm out of space here, so I'm just going to kind of show you what this becomes, I think. Okay, so this could turn into this, which we would wind up writing kind of like that. Let's get you to where you can see what I'm doing there. Okay, so as you enter these into your assignment, you're probably going to get to a point like there and enter something like that. So it may be long and tedious of what you're typing, but that will be fine. We won't go into simplifying this and factoring. So the big idea here is apply the derivatives using the rule for the quotient, which is the bottom times the derivative of the top. Don't leave anything like this unless it's implied in the instructions. Okay, and then if you will go to the next page, you have a problem you can practice with where you're trying to figure out which one is which is the f, which is the f prime, and which is the f double prime. Okay, so when you inspect this, you're going to be thinking about where's the slope 0 and where are those 0 values on the other graph, and going through. Okay, so pause the video and then come back and you can check yourself. Okay, so hopefully you've tried this, and at this point what you're thinking is the slope is negative here, the slope is 0 here, the slope is 0 here, which means if this was f, the derivative graph would have 0 values on it as x-intercepts at 1 and 3. Well, that's true here, but this is negative, which would imply that if this was the derivative graph, then the values of y would be down here. So this can't be right, okay? So be thinking about that. So since that's wrong, this is negative, a negative slope, the derivative values would fall below the line. That's the wrong answer. So this is not f, okay? Then you would come over and say, well, this could have a derivative of 0 here, so I'm looking for something with an x-intercept there. Okay, so it's not that. And there's one here. There's one here. And so that's kind of the approach that you use. Your answers come out to be f here, f prime here, and f double prime there. Okay, so use that and work on completing your higher order derivatives.